Welcome students. Today we are going to study class 9th physics motion chapter, a very important chapter that is required for having a base for the senior classes. So today we will study motion. Now what is motion? First of all, you should know two things. One is rest and the other one motion. When do you say an object is at rest or is in motion? Rest means when an object does not change its position. I'll repeat, when an object does not change in position with respect to an object. Means if I have an observer here and another object is here, if the position of this object is same with respect to this observer, we say it is at rest. Position is same with respect to the observer, then we say it is at rest. If the position of this object changes with respect to this, then we say the object is in motion. Now, you will say this always happen when object observes another one. Let's take an example what this observer makes, how this observer makes a difference. Let us say if somebody is sitting in the bus, another one is also there in the bus is moving, okay. With respect to this particular person, the position of this one, say this is object 1 and this is object 2. With respect to second, the position of one always remains the same. There is no change in their relative position. Then we say object 1 is at rest with respect to 2, although the bus is moving. But at the same, under the same condition, if my observer is outside the bus and stationary, my observer is stationary and the bus is moving in this direction. Now when the bus is moving, the position of object 1 also changes with respect to the observer. This is the observer here. So position of 1, 2, bus, they are changing with respect to this observer. Then we say they are in motion. They are changing their position. Initially the bus is here. Later on the bus will be here. So this position changes. Then we say this bus, observer, object 1, object 2, all of they are moving. So that is your, what is, when we say an object is at rest, when we say object is in motion. So whenever the position changes with respect to an object, then it is in motion. And whenever the position does not change, we say it is in rest. Now next students, let us study about scalar quantities and vector quantities. Scalar and vector quantities. Now, what is in scalar quantity? Whenever we talk about only the magnitude, not the direction. For example, if I'll say my speed is 5 meter per second. So this is 5 meter per second. I'm just talking about only the magnitude. I'm not talking about the direction. Which direction I'm moving? Then it is a scalar quantity. Means there is only magnitude. The other case, if I say my speed is 5 meter per second due north. Here I have mentioned the direction also. So whenever I have a magnitude and the direction both, I say this is a vector quantity. Okay. So some quantities are scalar quantity where direction is not important, where you are going. Some quantities are vector quantity where the direction as well as the magnitude, both of the things are important. So today we'll discuss some of them. For example, let us say this is a straight road. Object is at O position. Object from here moves to A, say 25 km. Then from A, the object moves to B, say 15 kilometers. And then object from B comes back to position C. Say the C position from O is 10 kilometer. Right? So, object starts from A, it moves to A, and then it moves to B and then stops. How much distance it has covered? 25 kilometers plus 15 kilometers. How much distance it has covered? It has covered 40 kilometers. Okay. Now, from B, it takes an opposite turn, U-turn, and comes back to position C. So, how much distance? 10 kilometer here. So, how much is this? 30 kilometer comes back. So, if you move your vehicle from here back to C, how much distance will be traveled? 40 kilometer plus 30 kilometer. That is 70 kilometer distance the object has traveled. This is a reading your odometer or the vehicle will show. You know what is the odometer? In your vehicles, there is a meter which measures how much distance you have traveled. It is irrespective of, maybe at the same point you're taking a round. Then also the reading of the odometer keeps on increasing. So odometer shows me how much distance I have traveled. So in this particular case, first it goes to position A, then goes to position B, and then comes back to position C. So the total distance covered is 70 kilometers. Okay. Now, this is the final position. O is my initial position and C is my final position. Right. So, when an object is at C position, how far it is from the initial position? It is only 10 kilometers far. 10 kilometers far from the initial position. The distance between the initial position and the final position is known as the displacement. Irrespective of, आप कहीं भी जाके वापस आ जाओ, but जो आपकी final position है और initial position, जो उसके बीच का gap है, the minimum distance between the initial position and the final position is known as the displacement. So, we have two things. One is distance and the other is displacement. Distance is the actual distance that you have calculated that you can see by your odometer. And the displacement is the distance, minimum distance between the initial point and the final point. That is known as the displacement. Okay. So, distance is a scalar quantity and displacement is a vector quantity because displacement depends on what is your final position. Maybe आप एक circle में घूम रहे हो, आपने यहाँ से start किया, round लगा के यहाँ वापस आ गए, ठीक है? तो how much is the distance traveled? The distance traveled is 2 pi r, the whole circumference. And what is the displacement? Again, O is the same position, A is again final position is same, so your displacement is 0. So if you come back to your initial position, we say the displacement is 0. In the same case, if this is my final position, I took half a turn and I stop here, then my distance covered is this much, that is pi r. And the displacement is the shortest distance between the final position and the initial position, that is this much. This is my displacement. And this is the distance covered. So, the distance covered and the displacement are two different things. Okay. Now, let us see the differences between distance and displacement. One is distance and the other one is displacement. This is the actual distance. This is the actual distance covered which your odometer shows, and displacement, distance between initial and final position. This is the first point. This one, this is a scalar quantity. We are not worrying about the direction. And this is a vector quantity. Distance covered is always zero, always positive. Distance covered is always positive for a moving object. अगर आप अपनी जगह से आपने मूवमेंट किया है तो आपका डिस्टेंस कवर्ड होने ही वाला है. फॉर अ मूविंग ऑब्जेक्ट इट इज ऑलवेज पॉजिटिव, बट अबाउट द डिस्प्लेसमेंट कैन बी पॉजिटिव, नेगेटिव और जीरो. पॉजिटिव when you are going from this position this position, this is positive. नेगेटिव आप यहां से आके और अपनी पोजीशन से पीछे चले जाओ. सो विद रिस्पेक्ट टू दिस आप पहले इधर जा रहे थे, अब आप इधर चले गए तो डायरेक्शन रिवर्स हो गया, तो डिस्प्लेसमेंट इज नेगेटिव. आप अपनी पोजीशन पे वापस आ गए, डिस्प्लेसमेंट इज जीरो. सो इट कैन बी पॉजिटिव, नेगेटिव और जीरो. Okay, so these are some of the important points about distance and displacement. Many a time this question is asked in the examinations. Okay, so based on the same concept of this scalar and vector quantities, now we'll study speed and velocity. Speed, scalar quantity, vector, velocity is a vector quantity. Means this will have only magnitude, this will have direction also. Okay, so same way, what about speed? Speed can be calculated by total distance by total time, but velocity is displacement upon time. So if your displacement is zero or negative, your velocity can be zero or negative. The unit for both speed and velocity is same, it is meter per second. How we got this unit? Say distance is measured in meters and time is in seconds, so the unit comes out to be meter per second. This is the SI unit for speed and velocity both. So one is a scalar, other one vector. This is the way we can calculate the speed, and this way we have to calculate the displacement. So if the displacement is zero, velocity can be zero. Okay, the next point can be, it is always positive for a moving object. It can be negative, zero or positive for a moving object. Right? Now students, now we'll discuss uniform motion and non-uniform motion. Uniform motion. Now as the word says uni means same type of motion, that is uniform motion. Okay, definition will be when an object covers equal distance in equal time interval. Equal distance in equal time interval, we say it is a uniform motion. Now what does it mean? It means that if I take the time interval to be say 10 seconds, and in the first time slot, let us say it covers 5 meter distance. Okay, in 10 seconds it covers 5 meter. So if I take another time slot of 10 seconds, it should cover 5 meter only. Okay, so if my time interval is same, my distance covered should also be same, then we say it is a uniform motion. Okay, contradictory to this, if we talk about non-uniform motion, means the motion is not uniform, it is not same throughout. In that case, when an object covers unequal distance in equal time intervals, then we say the motion is non-uniform motion. For example, Let us say the road is not uniform. Sometime you have to apply brake. Sometime the road is empty and you can pick up the speed. So your speed keeps on changing. So if your speed is changing means you will be covering unequal distance in the same time. So such type of motion is a non-uniform motion. For example, if I take again 10 seconds time interval, if it's sometime I'm covering 5 meters, sometime I'm covering 10 meters distance. So see, the time intervals are same, but the distance covered is unequal. We say it's a non-uniform motion. You can also have the distance covered is 5 meter, but the time is say 5 seconds and here it is 10 seconds. Then also it is non-uniform motion. Means one of the things should be unequal. Either the distance should be unequal or the time interval should be unequal. In such cases, you will have non-uniform motion. Practically speaking, most of the cases we have non-uniform motion because our road conditions are not same. Sometimes the roads are very smooth. Somewhere there are speed breakers are there, traffic will be there. They are not conditions are not always same. But this is a means ideal condition, uniform motion. When it covers equal distance in equal time, then we say it's a uniform motion, right? So next we'll study about next is, now if you say the speed keeps on changing, speed keeps on changing, the road is not uniform or there is a not uniform traffic is there. So what will happen? Initially say I'm moving with certain speed and suddenly there is a red light. The speed becomes 0. For some time you have to stand there. This is, let us say this is a speed time graph. Speed time graph. Initially I'm increasing my speed, the road is uniform, and then suddenly a signal comes, then I have to drop down my speed, I have to become stationary there, and then again after some time, again after green light, again I pick up my speed slowly, and then so in such cases where your speed is not uniform, you are going from your school, you are going home, and you have to decide with which speed I have traveled. मेरी speed क्या रही है पूरा स्कूल से घर जाने तक मेरी speed क्या है. तो इस टाइम पे देखो आपकी speed uniform नहीं है. You have at different time intervals your speed is different. Say here some other speed is there. At this point of time you have another speed. इस टाइम पे देखोगे तो आपकी स्पीड 0 है, यहाँ पे भी 0 है, वापस आपकी स्पीड इंक्रीज होनी शुरू होगी. अगर आप किसी एक पर्टिकुलर मोमेंट पे आपकी स्पीड देखते हो देन इट इज नोन एज इंस्टेंटेनियस स्पीड. मीन्स आप किसी एक इंस्टेंट टाइम पे देखते हो, किसी इंस्टेंट मोमेंट पे. एक मोमेंट पे देखोगे तो उस टाइम पे आपकी जो स्पीड होती है वो है इंस्टेंटेनियस स्पीड, लेकिन आपकी वो स्पीड थ्रू आउट योर जर्नी तो नहीं है. Sometime it is more, sometime it is less, and at sometimes even it is 0 also. So ऐसे cases में जब आपकी speed बार बार vary हो रही है and you have to say throughout the time what will be your speed, generally we calculate the average speed. How to calculate the average speed? This is equal to total distance traveled, total distance by total time. Means what you will do from school to home, you find out the total distance and how long you took to reach from school to home. आपको अपना total distance लेना है, total time लेना है, divide it, that is your average speed. Mostly we calculate the average speed when the speed is not uniform throughout. Okay, so this is the formula for the average speed, and most of the time this is the thing which we use. Okay, total distance by total time. And in physics, as I already told you, distance is represented by the symbol s, time is represented by t, and the speed we represented by say v. So this is velocity equal to distance upon time. The unit for speed is meter per second, because distance covered is in meter, time is in second. This is the SI unit of speed, meter per second. Now, if the speed has a direction, means then it is a vector quantity. Speed with direction. As I already told you, if I say I'm moving with 5 meter per second due north, then this is known as velocity. So speed with direction is known as velocity. So if you are moving in a particular direction and with the same speed, say 5 meter, you are 5 meter per second, you are moving in a circular path. So every moment your direction keeps on changing. आपका direction बार बार बदल रहा है ना हर moment पे. So इस केस में आप क्या बोलोगे, आपकी speed तो यूनिफॉर्म है लेकिन आपका डायरेक्शन बार बार चेंज हो रहा है. तो अगर या तो मैग्नीट्यूड चेंज हो या डायरेक्शन चेंज हो, हम बोलेंगे वेलोसिटी इज नॉट कांस्टेंट, इट इज चेंजिंग विद टाइम. ओके, सो इन केस द स्पीड इज नॉट यूनिफॉर्म, द डायरेक्शन इज सेम, देयर ऑल्सो वी कैन कैलकुलेट द एवरेज वेलोसिटी. Average velocity is given by the formula u plus v by 2. Now what is u? U is the initial velocity. V is final velocity. The symbols are important, you should remember them. U is initial velocity, V is a final velocity. So average velocity is given by u plus v by 2. Say if this is the diagram, this is the value of u, this is v, and this is time t. So you started moving with the initial velocity u, then suddenly you started accelerating your vehicle, maybe cycling, you are paddling your cycle, आपकी velocity जो है वो change होती जा रही है, आप speed up कर रहे हो. So finally at time t आप v velocity पे पहुँच गए हो. तो during your path your average velocity will be given by u plus v by 2. This is the formula for average velocity, right students?